No other fifth-generation fighter has been as extensively combat-tested as the Russian Su-57. Since at least June 2022, the Russian Air Force has employed formations of Su-57 fighters for air defense suppression, precision strikes, and long-range air-to-air engagements in the Ukrainian theater. The Russian military experiments with different operational models to refine their tactics. For example, one Su-57 provides electronic masking and high-altitude cover with R-77M missiles, while two Su-57 jets launch Kh-69 cruise missiles at high-value targets. This has been the platform's primary tool for dismantling Ukrainian air defenses from safety. The Su-57 has debuted the S-71K Kovyor drone missile hybrid. This is a loitering weapon that is used to perform target validation for electronic warfare jamming operations. Furthermore, the Su-57 is integrated in manned-unmanned teaming operations. In October 2024, a Russian S-70 Okhotnik heavy strike drone lost control due to technical failure. The accompanying Su-57 executed a pre-planned emergency protocol and destroyed the malfunctioning drone with an air-to-air missile to prevent the capture of its stealth technology by Ukrainian forces. The incident was a technical loss, but it demonstrated that the Su-57 has an effective AI-assisted control suite and is able to manage high-stakes unmanned coordination. But is the Su-57 really a fifth-generation fighter jet? While there is no single international treaty that defines the term fifth generation, the industry generally agrees on 5 core pillars. Older generations of fighters carried weapons on external hardpoints. Fifth-generation aircraft carry everything inside internal weapons bays to minimize its visibility to enemy radars. In older jets, the pilot had to look at 3 different screens for radar, infrared, and electronic warnings and fuse that data in their head. A fifth-generation jet uses integrated modular avionics to combine all sensor data into a single tactical map. The aircraft essentially acts as a flying supercomputer that tells the pilot what the threat is, rather than just showing raw data. Fifth-generation jets fly at supersonic speeds without using an afterburner. This lowers the jet's heat signature and saves fuel. Most fifth-gen jets use thrust vectoring, where the engine nozzles actually tilt to redirect thrust. This allows the plane to turn on a dime in mid-air to help evade incoming missiles and win a close-range dogfight. A fifth-generation fighter uses high-speed, low-probability of intercept data links to share its sensor data with friendly ships, ground troops, and even older fourth-generation jets to allow them to fire at targets they can't even see yet. Compared to the American F-35, the Su-57 is 20 to 100 times more visible to radar. But it's a calculated aerodynamic trade-off. The Su-57 has large movable slats on the wing root extensions to achieve super maneuverability, which increase its radar visibility. The Su-57 is designed to be stealthy enough to get close and use its massive speed to survive. It isn't an invisible ghost like the F-35. It's designed as a flying sniper rifle. For years, the Su-57 was underpowered. It used older engines borrowed from the Su-35. The new AL-51F1 engine is finally entering serial production. Its new exhausts hide the engine's heat from infrared sensors and reduce the radar reflection from the back of the plane. With these engines, the Su-57 will be able to achieve true supercruise without breaking a sweat. The Su-57's biggest weakness is Western sanctions. They have choked the supply of high-end CNC machine tools used in its supply chain. Russia is currently forced into imitation import substitution. They are trying to replace Western microelectronics with Chinese or domestic alternatives with varying degrees of success, and there is still a high dependency on Western technology. Forensic audits of downed cruise missiles have already identified transceivers from US-based Maxim Integrated. While the Su-57 has survived its Valley of Death development phase, its long-term future as a mass-produced fighter rests entirely on whether Russia can build a domestic high-tech manufacturing base from scratch.